A sequence of random variables can converge in probability without the expected values converging. Convergence in probability says the variable is close to the limit with high probability. Convergence in expectation says the mean distance goes to 0. The missing ingredient that connects them is uniform integrability. Without it, mass can escape to the tails even as the distribution concentrates. A family of random variables is uniformly integrable if its tails can be made small uniformly across all members. The same threshold works for every element simultaneously. This rules out families where some members have heavy tails that grow with the index. Uniform integrability controls the tails of the entire family, not just individual members. Almost sure convergence implies convergence in probability. L1 convergence also implies convergence in probability, but neither implies L1 convergence on its own. Uniform integrability closes the gap. If a sequence converges in probability and is uniformly integrable, it converges in L1. The hierarchy is not symmetric, and uniform integrability is the bridge. Consider xn equal to n on a set of probability 1 over n and 0 elsewhere. Xn converges to 0 in probability, but its expected value equals 1 for every n. Mass concentrates in a tiny region, but the value there is n. The product stays constant. This sequence is not uniformly integrable, and its expectations do not converge to 0. A non-negative martingale converges almost surely by Dub's theorem, but almost sure convergence does not imply the expected value is preserved. Without uniform integrability, the limit can have a strictly smaller expectation than the initial value. The martingale can converge to 0 almost surely while starting with a positive expectation. Uniform integrability is the condition that preserves the expectation at the limit. The Vitali convergence theorem gives a complete characterization of L1 convergence. A sequence converges in L1 if and only if it converges in probability and is uniformly integrable. Both conditions are necessary. Convergence in probability alone is not sufficient. Uniform integrability alone is not sufficient. Together, they are exactly equivalent to L1 convergence. Exchanging expectations and limits requires uniform integrability. Without it, this interchange fails even when the almost sure limit exists. The failure occurs because mass accumulates in the tails, the part the limit cannot see. Uniform integrability controls what happens at infinity. It is the real constraint on when expectations and limits can be exchanged.